Howdy. Our presentation today will be over the removal of crystal violet with applications of AI modeling using nanoparticles.
Hi, I'm Alex.
Hi, I'm Joseph.
I'm home.
I'm Sage.
So the types of nanoparticles used. So the nanoparticles that were used in this experiment were reduced graphene oxide supported with bimetallic iron and nickel nanoparticles. So basically, these nanoparticles were used to synthesize the removal of crystal violet dye from aqueous solutions, but mainly in real life applications, this would be from like ponds or like natural reservoirs of water because it is toxic. So the size of the RGO, iron and nickel nanoparticles, were roughly 44 to 81 nanometers, and their diameter was roughly 26 to 68 nanometers. And then on average, the diameters of the iron and nickel nanoparticles were approximately 66 nanometers to 42 nanometers. They didn't actually specify the shapes of the nanoparticles. However, they use morphology of iron and nickel through CHEM, which is a super highly ultra-defined microscope scanning technique called scanning electron microscope. So if you look on the image on the right, it kind of has like a DNA look-alike effect. And so that is just showing, since there's no actual shape, roughly what it actually looks like.
Okay, so for the application of the nanoparticles, they are used to remove crystal violet from wastewater because crystal violet is a colored dye that causes significant environmental problems. It's non-biodegradable, it's toxic. It contains a lot of toxic properties like carcinogenic and mutagenic properties. It reduces light penetration in water, which kind of inhibits the aquatic life ability to be able to photosynthesize, and obviously that reduces their ability to survive. And due to its molecular structure, this dye is very difficult to break down in wastewater. And just because of all these negative effects it can have on the environment, it's vital and necessary that we're able to remove this from wastewater before it's discharged into the environment. So this study determines that the reduced graphene oxide, iron, and nickel nanoparticles are able to effectively be used to remove crystal violet from aqueous solutions through the process of adsorption.
So what exactly do the nanoparticles do? And so the composite RGO iron nickel nanoparticles were used in these AI optimized conditions. So the AI optimized the contact time, the concentration, the contact time, the initial concentrations, and in order to figure out which concentration of this specific nanoparticle would be the most efficient in removing the crystal violet from the aqueous solutions. And so we were in the paper, they used it as an alternative to NZVI, which is zero valent iron, as an adsorption agent. The zero valent iron has a problem, like most metals, that it oxidizes in air, and this is actually the problem with iron nickel as well. But with the reduced graphene oxide, we're able to combat that a little bit more. So with these AI optimized conditions, we were able to get the most efficient nanoparticles for the process of adsorption, in which the crystal violet particles adhere to the outer edges of the reduced graphene oxide iron nickel nanoparticles in order to be cleared and efficiently removed from the solution. On the right, you can see um, all of the machine learning tests that have been done to figure out the most efficient concentrations.
There were many earlier methods to remove dyes, such as crystal violet, but they had their own disadvantages, which made them not very viable options, such as biological treatment, which had slow treatment times, like production of toxic intermediate byproducts, oxidation, which had high costs to and toxic byproducts, and photochemical degradation, which had high cost, limited efficiency with certain light sources or high dye concentrations. So to combat these, they uh, developed the process of adsorption, which is a superior method for the removal of dyes such as crystal violet, because it has a low cost and it is very easy to operate and has a very good efficiency in removing dyes due to the adherence of the crystal violet particles to the nanoparticles.
Awesome. So here are credits and references. We use just one document, which is the removal of crystal violet using reduced graphene oxide supported by bimetallic iron and nickel nanoparticles. And we got it through Citation Machine just to make the citation, and additionally through the website. Awesome. Thank you.
Thank you.
Thanks.